Hello everyone, I'm Tilaka, presenting on behalf of Design Group 2, and today we are very excited to introduce VoltLink, a smart energy monitoring and control system. So without further ado, let's dive in. Here's a quick look at what we'll cover today. From the problem that motivated this project, through our design and components, all the way to our outcomes and as well as limitations. 12 sections, and we'll go through them efficiently. We've done it all. Left the fan running or walked out with the AC still on. However, with the current electricity demand rising year on year, this kind of wastage adds up fast in both cost and carbon. VoltLink is our answer to that problem. A smart, affordable system to monitor, control, and optimize energy use in indoor spaces. So what exactly is the problem here? Appliances are regularly left on when they shouldn't be, driving up electricity bills. There's no easy way to track energy consumption at individual appliance level. And beyond energy, gas leaks, unattended devices create real safety hazards. And that's the gap VoltLink fills. For this project, we have 6 clear objectives. First, monitor device level energy consumption. Second, provide real-time data. And thirdly, to enable remote appliance control to detect room occupancy and send alerts when energy is being wasted. And last but not least, we have a safety layer as well to detect harmful gases in the environment. These 6 objectives shaped every design decision that we made. VoltLink is built around 4 core functionalities. Smart socket system, which lets users remotely switch appliances, an energy monitoring system for real-time tracking, occupancy detection to check whether the room is actually in use, and gas detection for safety. They form one unified smart space solution. So here's how the system is structured. At the base level, we have the input layer, which has 3 sensors. The ACS712, which measures the current flow. And we have a PIR sensor, which detects motion, and a MQ2 sensor, which picks up harmful gases. All those data flows to the ESP32 microcontroller, our processing layer, which handles the logic and sends everything over Wi-Fi using hypertext transfer protocol. And then the output layer takes over. A PC dashboard displays the data, a relay module physically controls appliances and voltage, which we are really proud of. Our AI assistant delivers smart alerts to the user. Here we have the 5 main components that we used in VoltLink. The ESP32 is the brain. It processes data and handles wireless communication. The ACS712, which is on the bottom, measures how much power each device draws. And the PIR sensor detects human motion, which is very important. The MQ2 gas sensor catches dangerous gases like LPG or smoke. And the relay module is what physically switches appliances on and off. All 5 of these components are very affordable, off-the-shelf parts, which was a deliberate design choice that we made in order to keep the costs down. Here's the working principle for our project. The sensors collect data. The ESP32 microcontroller processes that data, and it sends to a dashboard app. And user has the ability to monitor and control situation, and also issue control commands if they are necessary. It's a clean feedback loop: sense, process, transmit, and control. We have 5 standout features that define VoltLink. Real-time energy monitoring keeps you informed at all times. The VoLTE AI assistant sends smart notifications before small issues become big ones. And remote control means there's no need to physically be present in the room. Gas detection adds safety, which most systems overlook these days. And occupancy-based alerts flag when appliances are running in an empty environment automatically. This is the VoltLink dashboard. On the left, you can see the usage change. This is up by 16% compared to last week, which means the user needs to be aware of his appliance usage. And next to the usage change, we have top 6 devices which draw most power. And also we have a room control panel that lets you toggle appliances per room with a simple switch. And on the right, we have Vault AI panel showing occupancy status and gives override control. It's designed to be intuitive, no technical knowledge needed. Anyone with a simple idea about what's happening here can operate this system. And in terms of outcomes, VoltLink delivers on all 4 goals: improved energy efficiency, greater user awareness, enhanced room safety, altogether in an affordable system. On limitations, we wanted to be honest. This is still a prototype which only operates on low voltages. And there are certain constraints when it comes to sensor readings. Also, we still haven't developed a mobile application, which is our main goal at this point. And also, this system wholly depends on Wi-Fi connectivity. These are all clear targets for the next development phase, and we are really excited to bring it on. It should be called as VoltLink 2.0. At the same time, I'm really excited to introduce our brilliant team. It's a team of 5. Mr. Deshal led the project idea, and also he designed the whole system, and the coordination part was done by him. And Ms. Guno then handled all the documentation and presentation stuff. And I myself, I designed the user interface concepts, and Ms. De Silva, she contributed to the project by delivering the programming logic. She built it by herself, and Mrs. Disanayaka researched and verified all the hardware components. It was genuinely a collaborative effort, and we are really proud of what we have achieved here. To wrap this up, VoltLink takes a simple room and makes it energy aware. It reduces waste, improves safety, and puts control in the user's hands. It's a small step, but it's a meaningful one towards a much greener living. So, this is our VoltLink project. Thank you all for your time, and we are happy to take any questions you have in. Please contact through our emails, and thank you very much for your time once again.